Hello, we are going to do section 1-5 here, and we're basically going to solve some equations and look at some word problems in this section. Most of it should be review. You'll want some help on some of the word problems, and that's okay. If you need to if we need to set up some homework work times together on Google Meets, we'll do that. Okay, so first thing you need to know is what all this vocab is. An equation has an equal sign. Don't forget, it says that an expression is equal to an expression. So when you solve it, you're trying to find the value of the variable that will make it true. And when you have something like this, y equals 3x plus 4, this is an equation where y equals this, but it doesn't have one solution. It has many solutions that make it true. But when you have one variable, such as this guy, 2x plus 3 equals 5, you can solve it and get one thing to make it true. We're going to talk about what else? Solution set would be if there's more than one solution. And the other thing we're going to talk about is something called equivalent equations. And I don't know exactly what that is. Equivalent equations is when you have the same solution for more than one equation. So that's the one variable. A linear equation, one variable will have values in for m and b, and it will set equal to a value, and you'll just get x by itself. Here it is, equivalent equations. So because 2x plus 3 equals 5 and x equals 1 both have the solution of 1, we call those equivalent. But in this case, you have x squared minus 3x plus 2 equals 0 and x equals 1. They're not equivalent because there's two numbers that make this guy true. Remember, you would have to factor it. You would factor to x minus 2, x minus 1 equals 0. So x would be 2 and 1. And this is just x equals 1. So that's not equivalent because this one has an extra. So if they have the exact same solution set, we call them equivalent equations. Otherwise, they're just not equivalent. They're just equations. We're going to use some of the equation rules by adding to both sides and multiplying to both sides to solve these things out. We're also going to be doing some tricks like using math to get rid of fractions. And there's going to be more than one way to solve a lot of these problems, so just make sure you ask if you're doing things a little bit differently than me. Okay, first of all, you're going to get pretty good at this. I think most of us are going to start when you see problems like this and you look at it and you're like, ooh, gross. You're going to use your instinct. You're like, it is gross. So what do I not like? If you ask yourself what you don't like about this problem, all of you would say, I hate the fraction. So if you don't like it, get rid of it. How can I get rid of it? Well, you can't just multiply one side, but you can multiply both sides of an equation by the same number. And if you pick that number special, you'll be able to get rid of these fractions. So if I pick the number 20, because that's the least common multiple of 4 and 5, and I multiply everything by 20, I can get rid of these fractions. Because if you remember, you multiply by things on the top and you divide by things on the bottom. You could take 20 times 3/4 in your calculator, but if you take 20 divided by 4, that's 5. 5 times 3 is 15. You'll get 15x when you take 20 times 3/4. Then you'll take the 20 times the minus 1, which is minus 20, and that will equal, you'll take 20 divided by 5, which is 4. 4 times 7 is 28. And these are equivalent equations. If I solve this just using the fractions and just changing everything to fractions, it would be complicated, but you'll get the exact same answer as if you solve this guy. And this guy is a little bit easier for us. So if you add 20, you're going to get 15x equals 48. You will divide by 15. You're going to get a fraction. You're going to hit math 1. Math 1 is going to be the button of the day, I think. Be 48 divided by 15, math 1. X is going to be 16 over 5. It's not wrong to solve this out using the fractions in your calculators. You could add 1 to both sides and just take 7/5 plus 1 and hit math 1. That would give you 3/4 x equals 12/5. And you could either divide by 3/4 or multiply by 4/3. And if you type this in, you're going to get the same thing, but it's a little bit easier for you to clear out those fractions. So that's probably what you're going to want to end up doing. Let's move along here. Another method you could do is you can type using your calculator and use a button called the intersect. So on this one that we just did, if I type y equals 3/4 x minus 1 into y1, and into y2, I just type in 7/5, I can do second, calculate, intersect, and it would also solve the solution for me. Not many kids like to do this, but I'm going to see if I can show you how this would work to see if you like it. Okay, if we type in y equals, I'm going to clear this out here, 3/4 x minus 1. I know some of you like to do the alpha y equals. You could have done that too. And in y2, I'll do the alpha y equals. And that one is 7/5. And I graph them both. You're going to have two lines that cross each other. Now I'm going to clear this out a little bit. So this will be my solution. If you go to second, calculate, and you pick intersect, and you try to find out where they cross, if you hit enter, it'll automatically jump to what they call the second curve, and you hit enter, and it wants us to guess. Where do you think they cross? Just move your cursor a little bit closer over here. And the answer is 7/5. That would be the value that makes them both true, which is what we got when we solved that problem. Oh, that's not what we got when we solved that problem. 3.2 which is 16/5. So don't pick the wrong thing. We were solving for x. Mrs. Bruno really messed up there. You're solving for x, not y. 3.2, and if you hit math 1, that would change to 16/5. So be careful. X, not y. Going back, let's look at some special cases. What happens when I solve this guy? Well, let's get the x's together first. If I add 24x and I add 24x, I get 7 equals 17. Is that true? Does 7 equal 17? No, it's not true. Because it's not true, there is no solution. So this says no solution. And if you think about it, it's because this is the line y equals negative 24x plus 7. And this would be negative 24x plus 17. Those lines are going to be parallel and they would never touch. So there's no point that they have in common. Let's look at this one. You might notice right away what to do. You could clear out the fractions, but look what happens when I get my x's together. If I add 1/3 x to both sides, I get 3 equals 3. Is that true? Yes. When is it true? That's always true because these are the exact same line. And these guys have infinitely many solutions. Or maybe all real numbers. I don't know what the math lab is going to say, but these are the same lines, so they touch everywhere. So it would be infinitely many solutions. Okay, we're going to use some problem solving to solve some word problems. There will be word problems on your test. So we're going to do our best here. So there are about 232,000 words in the Japanese language. This is 19% more than the number of words in the Russian language. How many words are in the Russian language? So we're going to try to make a equation up here. So let's say we're talking about how many words in the Russian language. So Russian equals, well, what does it equal? There are 232,000 more words in the Japanese. So we got 232,000 in the Japanese. And this number is 19% more than Russian, okay? So if I take this and then I subtract 19% of the 232, 1, 2, 3, that should tell me how many are Russian. So if I take 232,000 minus 19% of 232,000, that will tell us that the Russian language has about 920. That wasn't even much of an equation. It was more of just computational. Let's look at this one here. In 2011, there were over 146,000 convenience stores in the U.S. The total number of convenience stores in Texas and California was this. So here's a fun fact. If you take Texas and you take California, you get 25,047. That's a fun fact. There were 3,885 more convenience stores in Texas than in California. So if you have Texas, it's not equal to California because Texas has more than California. So Texas is going to equal the California stores plus 3,885. So Texas is all the California stores and then 3,885 more. Now what you can do is you can take this and use substitution, plug it in for that Texas to figure out how many stores are in both in Texas and California. So I'm going to get California plus 3,885 plus California, and that'll equal 25047. You'll have to combine your like terms. There's 2C plus 3,885, and that'll equal 25047. Subtract 3,885. Get 21,162. Divide by 2. I ran out of space here, but if I divide that by 2, it says California is 10,581 stores. Then how many would Texas have? Well, you go back to your Texas equation, and that will be California, the 10,581 plus the 3,885, which is 466 stores. So this is our total, and then you have to figure out how those two are related and substitute them in. Motion formula, you will need to know that distance equals rate time time. That will help us on the next problem here. And here it is. Let's see if I can give myself some space here. Okay, so we have a Delta fleet has a cruise speed of 531 miles per hour. And then you have a Saab that has a 290 miles per hour. Suppose the Saab takes off and it travels at a cruising speed. So here's the Saab, just going, boom. That's an airplane, guys, just cruising. And then an hour later, so this 1 hour later, this other guy goes. 1 hour later. And the Saab, if you remember, goes 290 miles per hour. And this plane that goes an hour later is going faster at 531 miles per hour. So it's eventually going to catch it. If they get to be equal, when they get equal, how long is it going to take this guy to overtake this guy? So this is my Saab, and this is my Delta. So what we need to know is we need to know that rate times time equals distance. Okay, this guy also has rate times time equal distance. Well, the rate we know is 290. Do you know what the time is? No, that's what we're actually trying to find out. This will be 290t is the distance. 290 times however long it takes. This guy is going 531. Now, he doesn't go T for time. He went an hour later. So he has 1 hour less than the Saab because he's not traveling as long. And then that is his distance. They want to know when the two distance will be equal. So when will this equal this? And that is the equation we're going to solve. So we're going to have 290t equals, and I'm going to go ahead and distribute this, 531t minus 531. Let's get our t's together by subtracting. If you take 290 minus 531, you get negative 241t. equals negative 531. You divide, and you're glad that you have two negatives because we couldn't have had negative time, so this is good. 531 divided by 241, and the time is 2.2 hours. Now be careful. That's how long the sob was going, is 2.2 hours. How long for the delta? The delta would be 2.2 minus 1, or 1.2 hours. So you need to make sure you find out what they asked. They're asking how long will it take the delta to catch, and that would be 1.2 hours. So if you ever get something wrong on your math lab, make sure that you're answering the question they're asking. Make sure you're not accidentally answering for the wrong plane. Okay, compound interest or simple interest, it's just going to be the principal time to rate, time the time. And the rate we'll use as a decimal, like a 0.0 something. Principal is the initial amount that you invest, and T is going to be time in years. So Damarian has two students' loans, and it's $28,000, okay? One loan is at 5% interest rate, and then he has another one at 3% interest rate, and altogether he has $28,000 in the loans. After 1 year, Damarian owes $1,040 interest. So what is the amount of each loan? Okay, well, how much do we have at 5%? We don't know. But I know how much interest that would be. It would be 0.05 times X. Now, how much does he have at 3%? We also don't know, but I can't say Y. I want to just say X still, but if I have X here, it doesn't mean that it's split down the middle. What instead you have 0.03, that's the interest, but you have 28,000 minus however much you put at the 5%. If you put it together, you get the interest that they talked about. I just covered it up, which is 1,040. Let's put it over here because I didn't space my stuff out very well. This is going to equal 1,040. If I can solve this up, I'll be able to figure out how much I had in each account. So we're going to distribute here. 1,040 is 0.05x plus 0.03 times 28,000. That's 840 minus 0.03x. Let's combine like terms. That's 0.02x plus 840. That equals 1,040. Subtract 840. And that gives me 200 is 0.02x, and divide by 0.02. And we get x is 10,000. So that means there's $10,000 on the X account, which is the 5% account. And then you have 28,000 minus X, which is 18,000 at the 3% account. Okay, again, you will get extra practice with these. We'll make sure you're ready before you take a test if some of these are a little confusing for you. This one, they made a nice little table to help you see the table if you want to go that route as well. And this is just explaining what I just did. Let's look about solar panels here. In December, a solar energy farm, more than 9,200 solar panels were installed. A solar panel converts sunlight into electricity. The length of the panel is 13.6 inches, less than twice the width. So this is the width. This is 13.6 less than twice the width. So twice the width minus 13.6. The perimeter is 207.4. Perimeter goes all the way around. So that equals 207.4. What is the length and the width? Well, we're going to have to add that up here. All the way around, you're going to take W. Remember, this side would also be W. And this side would be 2W minus 13.6. So if you go all the way around, how many W's are you talking about? 2, 3, 4, 5, 6W minus 13.6 and 13.6. That will be minus 27.2 equals 207.4. If you solve this out, we'll be able to get the width. This is 234.6. Divide by 6, and this is going to give us the width, which is 39.1. If the width is 39.1 inches, then you will take 2 times 39.1 minus 13.6 to get the length, which will be 64.6. I think it was inches. It might have been feet. Let's see here. It was inches. Okay? So remember, perimeter goes all the way around. This is the last word problem, and they're going to talk about an idea called zeros. Metro Taxi charges $2.50 pickup fee and $2 per mile. Grayson's trip to the hotel is $32.50. How many miles did he travel? $2.50 is just to pick you up, and you get $2 per mile. If the whole thing costs $32.50, how many miles did he go? It's pretty easy. We'll just solve it up. 2m equals 30 divided by 2, and it looks like m is 15 or 15 miles. Okay, enough with the word problems, you say. The last thing is this idea called a zero. A zero is another word for an equation when it's set equal to 0. It's also called an x-intercept or a root. So all lines have one x-intercept, and that's what you're looking for. Your calculator can find them if you graph them by doing second calculate 0, but they're not hard to find by hand. So if they ask you to find the 0, they just want you to set this guy equal to 0 and solve. You'll add 9. 9 equals 5x, and divide by 5, and x equals 9/5. So a 0 is just a fancy way telling you to solve the equation by setting it equal to 0. Again, you can graph it and do second calculate 0, and it can also do that for you. Okay, we'll have time to practice with all these word problems. We're going to have a whole work day to catch up, so no worries.